Hello everyone, this is one question from GATE 2012 physics paper. This is question number 28, which is based on the basics of the electromagnetic waves. So here it asks that a plane polarized electromagnetic wave in free space at time t is equal to 0 is given by Exz, because at t is equal to 0, so there is no t, that is equal to 10 j cap exponential iota 6x plus 8z. Now we have to find out the magnetic field corresponding to this electromagnetic wave, but at x, z, t. Now we have to include time. So we will first see that and first establish a relationship between E and B, and then we will proceed for the answer. So to start with, let me go to the solution. So to start with, we will use the Faraday's law in Maxwell's equation. So there are four Maxwell's equation we all know, that is just a minute. So there are four Maxwell's equation we know, that is del dot E is equal to rho by epsilon naught, which is the Gauss law. Then del dot B is equal to 0, which is the divergence of the magnetic field is 0. And the third one is the Faraday's law, which is del cross E, which I have written also in this side. So minus delta B upon delta T. And the last one is the Maxwell's actual relation, which includes both the conduction and the displacement current density. So it is JC plus JD, the conduction current density plus displacement current density. And we can multiply by mu naught, because if we consider it to be a free space, we can multiply by mu naught, and JC will be 0, and in that case it can be del cross B is equal minus epsilon naught delta E by delta T, or only plus, into mu naught. So just let me write it again. So it will be nothing but mu naught epsilon naught into delta E delta T. So these are the four Maxwell's equation in brief. So this is the Maxwell's equation which we will use, that is that del cross E is equal to minus delta B delta T. From the wave equation of the electromagnetic wave, we get the solution in terms of electric field as well as magnetic field, which is like this, that is E is equal to E naught cos. You can write it in terms of exponential, in terms of sine, as well as in terms of cos. Nothing will change. So electromagnetic wave solution can be written in any way, say like this: a e to the power iota k dot x minus omega t or plus omega t, whatever you write, or it can be written as a cos k dot x minus omega t, or it can be written as a sine k dot x minus omega t. This k dot x, the k is the propagation vector, which I will just show. So this is the electric field of this electromagnetic wave. The wave solution can be written as like this: E is equal to E naught cos kxx plus kyy plus kzz minus omega t. So these are the vector dot product, so I have written it in component wise. B is equal to B naught cos kxx plus kyy plus kzz minus omega t, where omega is the frequency of the wave. Now E naught and B naught, these are the constant vectors. So we have to remember this: E naught and B naught are the constant vectors. And k is the wave propagation vector, that is kx I cap, ky j cap, and kz k cap. So it is the direction of the propagation. It shows the direction of propagation of the electromagnetic wave. Now, what I will do is that we have to, in the question, what the question says is that given that the electric field, we need to find out the magnetic field. For that, we need to know the relationship of this kind of wave propagation, which I have shown here. For this kind of wave propagation, what is the relationship between the electric field and the magnetic field? Or in short terms, it is we need to find out the relationship between the E naught as well as B naught. To establish a relationship between E naught and B naught, we start with the Faraday's law, which I have shown here, and I go to the LHS of this Faraday's law, this one. So this is that is del cross E on the left hand side. So this I am writing del cross E, and I am doing the curl. Okay, here E, this particular expression, that is E, I am writing it like this: E naught x, E naught y, E naught z, and this vector will not come, because just these vectors will not come, because this is nothing but the component. So since this is the component, the vector sign will not come. Okay, so now this is E naught x cos of phi, where phi I have written as this particular quantities which are in the argument of the cos. So E naught x cos phi, E naught y cos phi, and E naught z cos phi. Now when we are differentiating, any differentiation if we do, like delta delta x, one term I am differentiating, so delta x E naught y cos phi, right? So what will happen, this E naught y is a constant, so it will come out. It will be only the differentiation of this cos of phi. Now cos of phi, if we differentiate once, what will happen? It will be minus sine of phi. For all the terms it will be minus sine of phi, and then within the phi the differentiation will take place. That is delta phi by delta x, or delta phi by delta y, like that way. Therefore, so each and every term will be differentiated, and hence the cos phi will be becoming minus sine phi. Now del cross E therefore becomes minus sine phi. I will take it out from all the terms, and we write whatever the other terms are there. So if you do this particular curl of electric field, you get I cap ky E naught z minus kz E naught y minus j cap kx E naught z minus E naught x kz plus k cap E naught y kx minus E naught x ky. And after doing this, you continue doing this, and ultimately you will find out that this particular expression which is there here inside the bracket, whatever we are writing, it is nothing but k cross E naught. You try this k cross E naught and you will find out that we are getting exactly the same particular thing. That is, this expression will match. Therefore, this becomes the k cross E naught. Then what we are getting, del cross E comes out to be k cross E naught minus sine kxx plus kyy plus kzz minus omega t. This is the left hand side. Now what happens in the right hand side in the Faraday's law? So it is minus delta b delta t. So minus delta delta t of b naught cos whatever the expression which we have got as the wave solution, we are writing it like that. B naught is a constant again, so I will take it out, b naught. Now if I differentiate it with respect to time, this cos of this entire expression, it will, what it will happen? So it will be, cos will become minus sign. So this minus and minus becomes plus first, and after that there is a minus omega t. Therefore for that there will be a minus sign and there will be an omega, and cos will be replaced with sine. So ultimately we are getting minus b naught omega sine of this particular thing. So since LHS is equal to RHS, we are writing it like minus k cross E naught sine phi minus b naught omega sine phi. So sine phi with a minus sign chops out. So what we are getting the relationship as b naught, that is the constant vector, b naught vector is equal to k cross E naught by omega. This is the expression which we need to know to solve this particular question. We also know that the phase velocity is actually c is equal to omega by mod k. Therefore omega is equal to mod k into c. Therefore b naught is equal to, what we will write it in, put it in this particular expression, so becomes k cross E naught, whatever is there, and instead of omega we are writing mod k into c. Therefore k by mod k becomes k cap cross E naught divided by c. Therefore this is the expression which we are getting for b naught. Okay. Now also we have seen that b naught in terms of E naught. Now what will be E naught in terms of b naught in this kind of a wave? Therefore it will be, I just multiply c with this b naught. So c b naught is equal to k cap cross E naught. Now cross both sides with k cap, like the way I have done. So c b naught cross k cap is equal to k cap cross E naught cross k cap. If you solve this, it comes out to be E naught is equal to minus k cap cross c b naught. Now the solution actually starts here. So now what happens is that if you go to the question again, see there are 4 options, and in each case there are something like omega t term. So k dot x minus omega t. So minus omega t, but here it is some plus omega t kind of a term. Now see whether it is, I come to the solution, whether it is y is equal to a cos k dot x minus omega t, or it is y dash is equal to a cos k dot x plus omega t. in both the cases, the phase speed definition will not change. The phase speed becomes what? Omega divided by mod k. This definition will not change. Therefore, we first find out what is the Cp. So, given in the question that E as a function of x and z at t is equal to 0, that we have to remember, this is the thing. Therefore, in general, the wave solution, I have told you that it can be written in terms of exponential e to the power iota kx k dot x minus omega t, cos or sine. But in this question, it is given in exponential iota form. So we are writing it in exponential iota form. So E is equal to E naught e to the power iota k dot x minus omega t. Now what is x? X is xi plus yj plus zk. K is the propagation vector kxi cap plus kyj cap plus kzk cap. Now compare these expressions, and at t is equal to 0, therefore we will get E naught is equal to 10j cap, which is clearly seen. K will be equal to 6i cap plus 8k cap from this particular expression, because it is k dot x. So if you compare these two equations at t is equal to 0, then what we will get? K is equal to 6i cap plus 8k cap. Therefore mod k, the modulus of k, will be root over 100, and that is 10. Fine, this we can do. Now what we will be, based on the phase speed definition, what we will do? Omega is equal to mod k into c. Therefore omega becomes 10 into c. Therefore the actual electromagnetic wave for the electric field component, we will get E is equal to 10j cap, whatever is given, e to the power iota 6x plus 8z minus 10ct. Now check for some time t, this will be the electric field. Now check the magnetic field which is given in the question. See, this is minus 10 ct, this is minus 10 ct, this is minus ct, and this is plus ct. So plus ct or minus ct is not the answer. So whether it is plus or minus, it does not matter. C and D are not the answer, because this is not the omega. Omega is not equal to c, but omega is equal to 10c. Therefore these two options are gone. The C and D options are gone. Only left is A and B, and in both cases A and B, this is minus 10 ct. Therefore we don't need to write plus 10 ct. Okay, we can easily do it for minus 10 ct. Now had it been that all those options in plus sign, then we have to do it in a different way. But here in this case, since it is minus is given, so we will proceed like this. Now to find B, the magnetic field, we know that B is equal to this. This particular part will not change. Whether it is electric field or magnetic field, it will not change, because this is the propagation of the electromagnetic wave, which is in the same direction. Now we have already found out with the derivation of the Faraday's law that B naught is equal to k cap cross E naught by C. So we need to find out k cap. So k cap is nothing but k vector divided by mod k. So it will be 6i plus 8k divided by 10. E naught is 10j cap, we have already found out. Now just do a cross product k cap cross E naught. We get 6 by 10, 0, 8 by 10, 0, 10, 0. And finally we get as minus 8i cap plus 6k cap. B naught we have found out that as minus 8i plus 6k divided by C, the expression which we have already derived. So ultimately the B becomes, B is equal to B naught, that is minus 8i plus 6k by C into e to the power iota 6x plus 8z minus 10ct. Therefore option A is the correct option. If you see the question again, so this is the correct option, the first one. Minus 8i plus 6k divided by C exponential iota e to the power iota 6x plus 8z minus 10ct. Therefore A option is the correct option here. Other options are incorrect. So this is how the question needs to be solved. Thank you.